So what I'm doing is I'm taking some of the problems from the review packet that I think look a little bit intimidating, and I'm going to try and walk you through them. So the first one I'm going to work on is number 55. We have the cubed root of x to the negative 2/7 y to the 6th all over the cubed root of y to the 2/3 x to the negative 3/7. First thing I want to do is just make it clear that that is the same thing as the cubed root of the entire fraction. So x to the negative 2/7 y to the 6th y to the 2/3 x to the negative 3/7. Now I can go ahead and simplify. Okay, so I'm going to bring up this term into my numerator to make it positive. So I got the cubed root now of x to negative 2/7 x to the 3/7 y to the 6th all over, that is a cubed root, y to the 2/3. That's a 3, 2/3. And that comes down to, well, x to the negative 2/7 times x to the 3/7 is just x to the 1/7 because I add my exponents. So that's the cubed root of x to the 1/7, sorry about that, x to the 1/7 y to the 6th over y to the 2/3. Now I have y to the 2/3 on the bottom and I have y to the 6th on the top, and what I want to do is I want to break down those y's so that they cancel each other out. So I'm going to go ahead and rewrite y to the 6th as a fraction with a 3 in the denominator, and so the only way to do that would be to write the cubed root of x to the 1/7, I'm just rewriting this whole thing, x to the 1/7 y to the 18 over 3, because that is the same thing as y to the 6th, all over y to the 2/3. And so I need to go ahead and look at this term and simplify that. So I have 18/3 over 2/3. That, when I simplify it, is, well, I have 18/3 minus 2/3 gives me 16/3. So we are left with the cubed root of x to the 1/7, x to the 1/7 y to the 16/3. And that is the same thing. Now this is like kind of weird because it's obviously not simplified since it's an improper fraction, this 16/3. So I'm going to go ahead and rewrite this whole thing as the cubed root of x to the 1/7. Well, 3 goes into 16 5 times, so that's y to the 5th times y to the 1/3. And if that seems weird to you, think about it this way. How do I get y to the 16/3 out of y to the 5th, y to the 1/3? Well, I'd have to make a common denominator, which would be 3. So I'd have y to the 15/3, which is the same thing as y to the 5, times y to the 1/3. So 15/3 plus 1/3 is actually 16/3, and that's how I would get y to the 16/3. Now that we have it in this form right here, we can go ahead and do as we normally would do by pulling out what we need to pull out. So we have that y to the 5th, the third root of y to the 5th. Well, how many times does 3 go into 5? Let me break this down for you a little bit. It only goes in once, but we can go ahead and rewrite this to make it more obvious. X to the 1/7, that's already simplified, so I'm just going to leave it like that. I'm going to go ahead and rewrite y to the 5th as a product of at least one cube, which is y to the 3rd, y to the 2nd, extend that radical, times y to the 1/3. So I left y to the 1/3 as it was, but I expanded this y to the 5th to be y to the 3rd times y to the 2nd, because that is the same thing as y to the 5th. Now that I have in this form, I'm going to go ahead and take out my y to the 3rd. So now I'm left with the square root, or sorry, the cubed root, actually, undo all that, I'm left with, when I take out y to the third, it becomes y, when I take out y to the third from a cubed root, times the cubed root of x to the 1/7. We've already taken care of our y to the third, so we're left with y to the second times y to the 1/3. Okay, this is still looking a little funny. Let's see what we can do here. Y to the second times y to the 1/3. How can I write y to the second in terms of thirds? Let's see. Well, I can write y to the second as y to the 6/3. I want to try to combine these guys to see if I can do anything with it. So I'm going to go ahead and say that this is the cubed root. Oops, actually I keep forgetting this y outside of there. It's the same thing as y times the cubed root of x to the 1/7, y to the 6/3, it's pretty bad, 6/3, y to the 1/3, which would be y to the 7/3, because 6/3 times y to the 6/3 times y to the 1/3 is y to the 7/3. So I have y times the cubed root of x to the 1/7, y to the 7/3. Let me go ahead and write that down here. I have y times the cubed root, oops, x to the 1/7, y to the 7/3. Well, there is actually nothing more that I can do with this, because it actually is a simplified fraction, but just to make it a little bit easier for you guys to see that, I mean, this is not technically not a simplified fraction, but I just want you guys to see that I can't do anything with this term here. I could have just left it the way it was and it would have still been the same thing. To make it a little bit easy for you guys to see that, I'm just going to go ahead and show you that I can rewrite this as y times the cubed root of x to the 1/7 times, well, the cubed root of something is also raising it to the third power, so I'm just going to raise this to the third power. I'm sorry, not the third power, the 1/3 power. Y to 7/3, all raised to the 1/3 power because it's the same thing as taking its cubed root. And then we're left with y times the cubed root of x to the 1/7, and y to the 7/3 raised to the 1/3 becomes y to the 7/9, because I just multiply across. Just multiply those powers across. So, oops. So that's just y to the 7/9. Okay? And so I can just bring this guy over here, and I have y to the 9/9 times y to the 7/9 times the cubed root, oops, that should be 1/7 there, times the cubed root of x to the 1/7. So, do you see how I took this y and made it 9/9, and I just brought this y over there just so we could see it a little better and maybe combine those? So that's y to the 16/9 times the cubed root of x to the 1/7. Y to the 16/9 times the cubed root of x to the 1/7. Okay, and then if we really wanted to rewrite that so it was not an improper fraction, I could have the 9th root of y to 16th times the cubed root of x to the 1/7. And now we can see that from here we have, from this term right here, we have the 9th root of y to the 16th, which is the same thing as y to the 9th, times y to the 7th, times the cubed root of x to the 1/7, which, if I pull this y to the 9th out of the 9th root, I'm just left with y times the 9th root y to the 7th times the cubed root of x to the 1/7. I did a lot of steps there to make it look like this. I'm not sure how Mrs. Reiser is going to want you guys to have it look for the exam. This is also a really hard one. I don't know if you're going to have anything like this bad on the exam, but it's good for you guys to see all those steps that I did, because I just did a lot of like flipping things around and just doing little tricks that you're going to have to get used to in order to do well in the exam. So don't let this intimidate you. Just take it slow and rewind where you need to.